Hello everyone, my name is Maria, and today I will be discussing the GDP swings in the United States between 1929 and 1938. From the graph that was provided to us, we could see that there are several fluctuations in the US GDP during this period. The graph has been broken down into different segments. From 1929 and 1932, the GDP shows a significant decline, reflecting the Great Depression. Between 1933 and 1936, there was a rise in the GDP as the economy began to recover. This was due to the New Deal. In 1937 to 1938, the GDP saw another sharp decline, and this was due to the recession. In conclusion, the GDP fluctuations between 1929 and 1938 reflect on a combination of economic disasters, government interventions, and global factors. GDP also stands for gross give me 1 second, sorry. Gross domestic product. And it is a total market value of all finished goods and services produced within a country's border over a specific period of time. Now it's time to create a piecewise function. And to create a piecewise function based on the given graph of the GDP curve for the US from 1929 to 1938, we need to break the graph into different segments and create a mathematical model for each segment. So this is the first segment. We have 0 and 1050, and then we have 3 and 750. This is the equation that you will be using. It would be m equals y2 minus y1 over x2 minus x1. So the first equation would look like this: 750 minus 1050 and 3 minus 0. So you would calculate that, and this would be a negative 300 over 3 equals negative 100. So this would be considered the first step, and the equation for this now would be y equals negative 100 So this would be the first segment. Now this is the second segment, and you have 3, 750, and 6 and 1,000. Again, you're going to use the same equation. So m equals 750. No, sorry. It's 1,000 minus 750, and you would have 6 minus 3. And the total for this would be 250 over 3, and this equals 83.33. And this would be 750 equals 83.33 times 3 plus b. Okay. The second step after this would be 750 equals 250 and the third step to this would be just pretty much subtracting both of these to get the value of b, which would be 500. So the equation, the final answer for this one would be y 8 3 plus 3 3 500. This would be the final one for segment 2. So for this problem, we are gonna go ahead and solve the third segment, and the vertex for this one is 7 and 1,000. And for this equation, you would be using y equals a parentheses x minus h to the second power plus k. You will substitute h and k for 7 and 1,000. The next step from this, we are going to use the points 6 and 1,000 to find a. So 1,000 equals a is 1 to the second power plus 1,000. So I've realized that I have made a mistake, and you would fix x and change it to 6, and this is how you got the 1 by subtracting 6 and 7. So now you want to go ahead and bring down 1,000 equals a plus 1100 A equals into. So now all you would do is subtract these two, making it into 100, and this equals to negative 100 times x minus 7 to the second power one. This is the final equation for segment 3 that you would need. This would be the last segment that you would need, and you would need to write the equation for the linear segment. And this is how you would write it down. You would just solve this, and this, the top portion would equal to 350. And you just subtract again the bottom one equals to 1. 350 divided by 1 is 350. And then for step 2, you're going to want to find the y-intercept. So it would be 1000 equals 350, which would be this. 350 times 8 plus b to now to solve this, all you would have to do is times these two, so you would bring down the 1000 again, equals, you would put 2800 and bring down that b. After doing that, you're just gonna want to subtract both of these, and it would be 1. You bring down the b, equals 1800, and the equation for this would be y equals 350 x minus 1000. No, 1800. This would be the segment for part 3. Now that we have all the equations for all 4 segments, we can now write a full piecewise function, and this is how it would look. So you would add all the equations that you had, and we're gonna put them all right here. So it's 100x plus 10, 50, 8, 3.33 plus 500. The next one would be negative 100 x minus 7 2 plus 1,000. And the last one would be 350 x minus 1,800. Now, I know it's a bit messy. It's kind of hard to write on this, but go ahead and do the piecewise equations now. And it would be 0 less than equal to x 3 less than greater than equal to x less than 6 it would be 8, and the last one would be 8 and less than 9. So this would be the full piecewise function that I had come up with. And to find the domain in the piecewise function is the set of the x value over which the GDP curve is defined. From the graph, we know that the GDP curve span is from x equals 0, which is 1929, to x equals 9, and it's from it's to 1938. And the domain for that would be 0 less than equal to x less than to 9. This would be your final answer for the domain after doing all 4 segments. For the next question, it's deciding the type of function that you would use for this graph, and I have chosen the linear function. When it comes to a linear function, it has constant rate of change when the graph is a straight line between 2 points. We use a linear function. Yes, the shape of this graph also helped me to figure out the type of function that I was going to be using. Now, to apply the concept of the limit, I have chosen one example of fixed costs for the surfboard manufacturers, and that would be the rent of the manufacturing company, because that amount does not change no matter of how many surfboards they have sold or even produced. An example for variable cost would be the cost of labor needed to produce each surfboard, because it will increase or decrease depending on how many surfboards were made and even sold. For question 2, from what I've picked up, the key differences is that the average total cost provides the cost per surfboards, while the total cost, sorry, let me rephrase that. The average total cost provides the cost per surfboards, while the total cost gives the overall cost of all surfboards produced. For the limit from the for the limit form the graph, we need to look at the behavior of the curve as x increases. If the graph flattens out, the cost of surfboard is less than the $10. I will go ahead and write the mathematical expression for number 3. I had to skip it because I had to put the whiteboard, but it would be C X this would be the mathematical expression, and for the limit it would be form. If it flattens out at the cost of $10, it would be C X equals 10. And you still want to add the X. Okay, so these would be my mathematical expressions for part question number 3. Now the next question asks, does the average total cost equal 0 at the large production? And I believe that no, the graph does not indicate that the average total cost will equal 0 when produced in large numbers. Sorry, no, the graph does not indicate that the average total cost will equal to 0 when produced in large numbers. It is a no because there will always be a fixed cost like rent or equipment. So that's something that won't change. So it would have to be a no. For the last question, economies of scale and average total cost. And I believe that yes, the graph suggests that the company may achieve economies of scale by increasing production significantly. If the graph shows a downward sloping portion, it implies economies of scale, meaning that the production grows and the company is able to reduce cost per unit. So this concludes all my information. I hope you guys enjoyed it, and thank you again for your time.